We are group number 8, and we hope you enjoy our project.
Julia, Paul, and I were group 8, and for our project, we found and graphed the second derivative of f of x equals 8 over x minus 5. In order to find the second derivative of the function, we start by finding the first derivative. In order to find the first derivative of the function f of x equals 8 over x minus 5, we'll use the chain rule.
As you can see, we completed this process by taking x minus 5, multiplying it by the derivative of 8, which is 0, then subtracting that by 8 times the derivative of x minus 5, which is 1.
Now that we've finished the low d high minus high d low process, we found the new numerator. In order to find the new denominator, we'll just simply square the original denominator, giving us x minus 5 squared. Now that we've reached the first derivative, we'll simplify it to get negative 8 over x minus 5 squared. Once we do that, we'll expand the bottom to get x minus 5 times x minus 5 and FOIL that to begin work on the second derivative.
Using the FOILing method of x minus 5 squared, we got x squared minus 10x plus 25. To explain how we solved for the second derivative, we took x minus 5 squared, which is x squared minus 10x plus 25, multiplying that by 0, the derivative of negative 8. Next, we subtracted that by negative 8 times the derivative of x squared minus 10x plus 25, which is 2x minus 10. After solving for the numerator above, in the low d high, high d low method, we square x squared minus 10x plus 25 to get the new denominator of the second derivative. Next, we simplify x squared minus 10x plus 25 times 0 minus negative 8 times 2x minus 10 to get our simplified numerator, which is 16x minus 80. At this point, our denominator is already simplified, so we just bring it down, as it is x squared minus 10x plus 25 squared.
In summary, this is our function, this is our first derivative, and this is our second derivative.
So in order to find the intervals, we found the second derivative and then set it equal to 0 and then solve for x. We found that the intervals of the function are negative infinity to 5 and then 5 to positive infinity. Over the first interval, which is negative infinity to 5, we found that the graph is concave down because when an x value is plugged in for that interval, for instance 4, the result is negative. Then, if you do the same for the other interval, 5 to positive infinity, and plug in a number from that interval, for instance 6, then you get a positive result, meaning this interval is concave up. The intervals of the function are negative infinity to 5 and then 5 to positive infinity. We can confirm this is true by looking at the graph, and then we can also see that there are no inflection points.